Good morning, guys. I would like to touch base a little bit with you about definition of vectors versus scalar. Okay, and then the other thing that I wanted to talk about is about graphing, okay, and the shape of those graphs. Okay, so first of all, definition of vectors. Please take notes, okay? So those are the notes you will take on 9.3. So let's write like notes 9.3. Post your notes, okay, in the opposite space, okay, on your calendar and assignments, whatever you have. So what is a vector? Okay, so let's start actually with a scalar just because, right? So scalar, quantity that gives only a number. Okay, so example, okay, you go on the scale because it's a scalar, right? So you go on the scale, okay, you go right here, so this is you on the scale, okay, and you will read a number. Do you have any other information besides a number? Well, on the scale, no. So only number, like we said. So for example, 400 pounds, this is a big person, right? So 400 pounds, it's just a number with the unit, okay? But this is a scalar, right? You take your thermometer, okay? You measure your temperature, so that's a thermometer, okay? You measure your temperature and you read 96 Fahrenheit, okay? Again, unit, okay, but this is your number, so this is your scalar, okay? So this is your weight, this is your mass, okay? Actually, this is your weight, okay? So this is your temperature, okay? Then you weigh nothing. Then you take a amount of stuff, okay, and you see what is the mass of this, okay? So mass, okay, and you will measure, for example, 100. What is the unit of mass in America? It's actually slug, okay? So if you say pound, this actually is a force, okay? If you say slug, this is the mu unit for mass, okay? But if you're thinking about a different system, I might be partial because I'm Italian, but for example, you will say 100 kilograms, for example, okay? And that will be still mass, okay? So it's just a number with the units, so this is also scalar, okay? What other things can you think about that have scale numbers, scalar numbers? So this is you. I'm an artist by heart. So I want to measure your height and I will say, okay, you're 6 feet tall. Okay, whatever, 6 feet tall. Okay, so that will be your height. Okay, and this is still your scalar. This is still a scalar, okay? So for all those numbers, I have only numbers, okay? Yes, I need the units to know or how many cupcakes are in this thing, right? In this case, 6. So 6 cupcakes, okay? Only number, so this is also scalar, okay? What other scalar quantities can you think of? How many people are in the class, for example? I don't know, you have, so um, this is your, okay, again, still, those are students, okay? So you can say we have 24 students in class, okay? Scalar. You're driving your car, okay? This is a car. I don't need comments, but this is a car. And this car is going at 20 miles per hour. Quantity, which is a scalar because it's only a number with the unit, okay? So all of those are scalars. So when do you actually start having vectors, okay? Uh, Vectors require scalars plus direction, okay? So if to the speed of before, okay, this is still your car, okay? And you're saying you're going 20 miles per hour. But if I say north, okay, now I have scalar, I have direction, okay? So I have a vector, okay? And when I draw this, okay, if I want to say, okay, this car is going 20 miles per hour north, I will just go like this, 20 miles per hour. I see is north because I'm drawing the arrow there. Scientists are kind of lazy to that respect, with that respect. We don't like to have so many words. So I like to draw just my picture, right? Now, if instead I want to say, okay, I'm starting now, look how longer this is, okay? I start from home, okay? And I go um, at 25 miles, oh my goodness, miles per hour uh, in a direction that is at 20 degrees north from east. This is so boring to hear it, right? So what would I do? Me, little scientist that is super lazy. I will just draw a, um, a coordinate system. I will mark there, okay, the direction first, north. So I will try to look for the direction north from east. If this is north, this one is east, right? Never eat soggy waffles. North, east, south, west. So you're starting from east because it's 20 degrees north from east. So you're starting from east. Okay, so you start here and you go 20 degrees north. Now I find this little dot there. And I want now this vector, okay, this arrow to be 20, I'm sorry, to be 25, okay? Because I'm saying it's 25 miles per hour at 20 degrees north from east. Does this make sense? So if I want you to draw another picture, okay? And let's see if you can actually see it. So this is my coordinate system, okay? And I say, I want to go. So I start from home and I go at 50, okay, miles per hour in a direction that is 30 degrees south from east, right? Again, I'm starting from east. So this is east, okay? And I'm going 30 degrees. So I take my protractor and I mark the 30 degrees south because it says I got to go south starting from east. So I go from here, I start to go south because if this is north, this one better be south, okay? So I follow the protractor, this is 30 degrees, and I go like that. So now this is the direction that I'm marking. Okay, so this is the 30 degrees, and this one has to belong 50 miles per hour. Okay, so now this 50 miles per hour, 30 degrees south from east is basically this. What if I want to join those two directions? What if I want to say, well, I'm going 25 miles per hour, 20 degrees north from east first, and then I go 50 miles per hour in a direction that is south from east. What would they look like? Well, you just take those and you superimpose, right? So basically I take this, let's make it, if this is 25, let's make it at least twice, right? So this is now 50, okay? So I take this, I drag it there, okay? But I drag it in such a way that I cannot rotate it. I only have to drag it. So at this point, let's say that this is the vector that I'm just dragging, which means if I draw an horizontal line, which is basically this portion here is going to be all here. So this is still 30 degrees. Okay, but now I have this vector 25 and this that is 50, right? So how do I find the final component here? Okay, so the final resultant, we call this the result of our motion, okay? So this is basically our final velocity, okay? So I have this velocity, I add this velocity, just drag it up and I join it head to toe, okay? And I find at the end, well, instead of going round and around, I could have just gone straight in this direction. I would have made the same point, right? But just to make the same point means probably I would have crashed against some homes, right? Against some trees. So probably I was supposed to go like this because there were obstacles in the middle, right? So I'm going straight in this direction to find the resultant. Okay, so this is your resultant. Okay, so now how do I calculate? How do I put all of this in a table? Okay, if I want to know the number of this velocity, okay, what would that be? Well, I want you to draw a scheme basically, okay, table that looks like this. Okay, here I have north, here I have east. Okay, so I have basically my y component and my x component, right? So then I have, this is my first velocity, this is my second velocity, okay? So first velocity is 25 miles, okay? But it's going to be, so what did we say? The first velocity is 25 miles, but is at this particular direction. Now question, can I just go here and write, or do I need to do something else before? Probably because I want to break this vector in horizontal and vertical quantities, I cannot just say, right? So let's write it here. So this is what the vector looks like, right? So this is my 25, and this is the 20 degrees. I need to break it down in horizontal and vertical, which means I can only go horizontal first and vertical after. And I got to hit this component here. So let's say talking with friends, I can say 25 miles per hour, 20 degrees north from east. But when I'm talking table wise, I cannot just say that. I got to say the number only horizontal and the number only vertical. So if this is 20 degrees, how much is this? Well, if you know your trig, right, you know that this, because this is your angle there, so this is going to be 25 cosine 20 degrees. And this instead is 25 sine 20 degrees. Those are the numbers that I will put here. So this is going east, so will be here, 25 cos 20 degrees. This is going north, so will be 25 sine 20 degrees, okay? So that will be the components that put together will make me go from here to here. Okay, so I will need to go horizontally first and vertically after. So my abilities, you got to imagine that they don't allow you to make angles. Okay, you have broken knees. You cannot just make turns. Okay, you just have to go horizontal first, vertical later. Okay, so what about this one? Same thing. I cannot just turn. My knee is broken. Okay, so I need to go in this direction first and then this. So if this is your angle, this is 50 sine 30 degrees. This, okay, is, I'm sorry, cosine. What am I saying? 50 cosine 30 degrees. This one is looking at the angle, is facing it. So this is 50 sine 30 degrees. Okay, and you will write it here. So V2 horizontally is 50 cosine 30. This is horizontal. Sorry, horizontal. I just switched this, so now I'm making it more complicated for myself. So east is this one, okay? So east 50 cosine 30, okay? And this instead north and south is going down. So it's going to go negatively south, north, negatively north, okay? Minus 50 sine 30 degrees. Negatively north means south, right? So how do I find this vector here? Well, I just have to add those components, okay? So what I can do is I'll just type stuff, okay? So 25 times 20 sine, and then minus 50 times 30 sine equal. So the result is negative 16.4. And this side instead, I have a 25 times 20 cos. My calculator is now high speed times 30 cos. Okay, so this is going to be a 66.8 because it's 79, okay, 0.8. Now I have both components, okay? And actually it makes sense because you see, this is horizontally, so it's so much longer when I put those two together, right? You see how the final one is? So it's so much longer horizontally, okay? But then I have to go south to hit it, which is negative, which makes sense. So how do I find the resultant? Well, just like in any geometry class, you will do your x component, so 66.8, and you got to square it plus negative 16.4 squared, which obviously is going to be a positive number, and square root it. So your final answer will be, so this one you just square it, and then you add 16.4 squared. Obviously, I don't do the negative because I don't care, it's still going to be positive. And then this is the final answer, and then you will do the square root of this, and you will find a 69, basically. Okay, 69. What was the unit? Miles per hour. Okay, so that would be your velocity. Okay, if you would have told somebody, I'm going this much first, okay, and then this much later. So my velocity, my resultant velocity, what would that be? And this is your final velocity. Okay, I hope this makes sense. Now, if you wrote everything, okay, post those into notes 9/3, okay, and submitted. And I'm going to leave you a small worksheet where you have to add two vectors and show me exactly the same steps. I want to see the vectors added together, okay, and the final resultant, okay? So if I say, okay, you have, so problem number one, okay, you have V1 equal to, for example, 30 miles per hour. And then we say at, okay, 30 degrees south from, south from west, okay? And then V2 instead is 10 miles per hour, okay, at 10 degrees north from east. So what would you do? So I want you to draw this, okay, is your 30 miles south from west. So do the angle first. So take your protractor, start from west and go down south. So start from here and go down south. So this is your 30 degrees, right? This is the direction, and you will stop at 30. So let's say that this is your 30, okay? 30 miles per hour. And this is your 30 degrees, okay? So I need you to give me this component and this component to set it in the table, okay? You will write, so this is your V1, so you will have V1, again, this is, I don't know if you want to put east first and then north, just mark it in such a way that I understand what you're saying, okay? So east is going to be your negative east, right, is in that direction, so this is your negative. Now, what is this number? This has to be 30 cosine 30 degrees. 30 because it's this, 30 degrees because it's the angle, right? So negative 30 goes 30. And then this is negative north, okay, which is negative 30 degrees, 30, the magnitude, sine 30. I put too much 30s. Okay, so let's change this one into 20, otherwise you might be confused, okay? So the second one instead, okay, is going to be 10 miles per hour, 20 north from east. So you start from east, okay, and you go 20 up. So let's say that this is your 20, okay? 20 degrees and 10 miles, so you got to go, for example, right here. This is 10. So I need you to give me the horizontal and the vertical. The horizontal is this one, which is 10 cosine 20. And this one, which is 10 sine 20. Okay, so east, 10 cos 20. And then this, which is 10 sine 20. This is your V2. Add them up according to the numbers, okay? Make sure that I can see this number here, and then you take number 2, number 3. So your final answer will be, okay, your number 1 squared plus your number 2 squared and square rooted, okay? So chances are you're going to have maybe 5 of those problems. I want you to do those, okay, and post it for 9. So this is going to be 9-3. So this is going to be 9-3. Okay, is your assignment for the day. If you, I don't know how long it takes your class. I mean, how long your class is. So if you need to put a 9-4, obviously it's still okay. Okay. And I'll post later on, okay, a video about the graphing and the meaning of those shapes. Have a great rest of your day.